Hello, Algebra. Algebra 2, Semester 1, Practice Final Exam. There's about 40 questions, not about, but exactly 40. So I think I might make this video two separate videos. 1 through 20, 21 through 40. All right, let's get going. Number 1, what are the domain and the range of the function defined by this guy, written in set builder notation and interval notation? All right. Domain. This is an absolute value function, so I like to do a little sketch so I can visualize it. It is, remember, opposite same for the vertex, just like parabolas. We would go to the left 5 and down 3, and then our legs go up 1 over 1, up 1 over 1. And the important part here is the left and the right is the domain. It's going forever to the left, forever to the right. So our domain is all real numbers. Set builder, I would say x such that x is all real numbers. Or sometimes they'll just put the r after instead of x is. Either way is fine. And in interval notation, negative infinity to positive infinity. And then our range is about bottom to top. This has a bottom at -3, the y value of the vertex, and it goes forever upward. Set builder, range is the y values, y such that y is greater than or equal to -3. Interval notation would be bracket -3 to infinity. Interval notation always goes smallest to biggest. Find where the following graph is increasing and decreasing. Okay, I am gonna mark the ordered pairs of the turning points, the relative max and relative min. Turning points is where it changes from increasing to decreasing or the other way around. So I can see here we have this ordered pair is -3. I don't want that to, there we go, -3, 0. And then we have a relative minimum at -1, -9. So when we say our increasing and decreasing intervals, it's all about the x values. So I'm just going to be concerned with the x values and the x-axis. So I'm thinking about the left and right values. And this graph doesn't show the arrows, but it's going forever down on the left, forever up on the right. So increasing and decreasing is start on the left, the way we read from left to right, and just trace it. Whenever your pencil's going up, you're increasing. Whenever it's going down, it's decreasing. And then after here, it's got that little curvy bump there, but it still is increasing. All right, so increasing in 2 spots, here and here. And it's the x values. So on the left-hand side of our x-axis, -infinity to positive infinity. So we're increasing. Looks like it's going just down, but it's going out, 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 out. So our x-axis, it's going from -infinity to -3. And then our other, I could do the union symbol, or I could just put a comma. But we write these in interval notation. My cat is jumping around here. -infinity to -3 in union with -1 to positive infinity. And we always use parentheses on increasing and decreasing intervals. Decreasing is when our pencil's going down from -3 to -1. What transformations change the graph of f of x to the graph of g of x? F of x is the parent parabola quadratic function, and g of x you can see here. So what is happening here, its vertex is 3, 1. The x value, 3, 1, would be over 3 and up 1. So the x value tells you left, right, the y value up or down. So it said to just what transformations. So this graph has gone to the right 3, opposite, same, and to the up and up 1. Pretty straightforward. The function f of x equals x squared. The graph of g of x is f of x translated to the right 6 units and down 3 units. What is the function rule for g of x? We're going to write its equation. G of x is equal to, so if it goes here, the vertex is at the origin. So if we go to the right 6 and down 3, there would be our new vertex. That's 6, -3. And there would be our parabola. So our equation would be x minus 6 quantity squared minus 3. Opposite, same. Number 5, the graph of f of x is shown below. If g of x is the result of translating f of x up 4 units and to the right 1 unit, what is the equation of g of x? Okay, so f is this guy, absolute value. We have to go up 4 and to the right 1. 1, 2, 3, 4 up and to the right 1. So this would be our g of x. And the legs have a slope of 1, -1. G of x. And that vertex is over 5 and up 2. Oops. 5, 2 for our vertex. Now we can write g of x's equation. Absolute value of x minus 5 plus 2. Opposite, same. It's vertex 5, 2. Which rule defines the function in the graph shown? We've got a piecewise function. So y or f of x is equal to, and there's 3 of them. So we've got to say each one of them. And piecewise functions, they say the equation of that line segment and the domain that it's in. So let's start with this guy. That is a horizontal line through negatives. This looks like it's going by 2's. So that would be through -6. So y or f of x equals -6. And now its domain. That's the x values. It is going from -10 to +2. Open circle on the -10, closed circle on the 2. So our domain, -10 is less than x, is less than or equal to 2. It's that closed circle on the 2 and not on the 10, -10. Let's do this one next. All right, so to write an equation of the line, we need the m and the b, the slope and the y-intercept. So what I need to do, let's do the slope first. I'm looking for points where it's going through exactly up 2 over 1, up 2 over 1 in a positive direction. So our slope is 2 over 1, or just 2. And now the y-intercept. So I have to just extend this line so I know what its y-intercept would be. Down to, so I'm going to continue that pattern, that slope. So it would be crossing through 0. So its equation, y, or f of x, equals 2x plus 0. I don't need to write the plus 0. And now its domain. It is going from 2 to 8. 2 to 8. Open circles on both. 2 is less than x is less than 8. And finally, we'll do this guy. That has a slope of -1. It's in the negative direction. And again, I need to extend it so I could see what the y-intercept of that line is. And it's crossing through 2. The y-intercept at 2. So its equation, f of x is equal to -1x, or just negative x, plus 2. And its domain between 8 and 16. Closed circle on the 8, open circle on the 16. So 8 is less than or equal to x is less than 16. Piecewise functions. Number 7, use a graph. What is the solution of the inequality x squared minus 25 is greater than 0? All right. This is a quadratic expression. And I'm noticing it's the difference of squares also. So if I were to factor it, remember that factoring a quadratic tells us the roots, the zeros of the graph. And this would be x plus 5 times x minus 5. So to get those roots, we solve it for 0. So x is -5, and for this guy, x is +5. +5 and -5. So our parabola, and it's a positive a value, so it is opening upward. I don't know how far down it goes, but that part doesn't matter, because we're just interested in where are the zeros, the roots. And we're looking now at that inequality. Parabola is greater than 0. So where is this parabola greater than 0? That means it's talking about the x-axis. It is greater or above the x-axis. I didn't put arrows on my parabola. In 2 separate sections. So we've got to say those x values of the 2 separate sections. So the section on the left, much like the other graph, it looks like they're going straight up, but they're ever so slightly going out, out, out forever. So it's going forever left and forever right on the other side. On our x-axis, -infinity on the left, +infinity on the right. So this left-hand section of the parabola is from -infinity to -5 in union with, and the right-hand section is from 5 to infinity. And there we go. That's our answer. That's where the graph is positive, greater than 0. Solve the system algebraically. And we should talk about in class 2 how we can do these on the calculator. I can't do it here because I don't have a screen of the calculator to show you. So we'll do that in class. But for doing these, I'll do them all longhand. Okay. They are in standard form. X, Y, Z equals a number. So when there's 3 of them, what we have to do is we're using the addition method where you add two of them together, but we want to do it in such a way that one of our variables will cancel. And so just looking these over, I don't have the same, looking at the x's, I don't have the same coefficients on any of our variables. So we're going to have to use multiplication to help us. So if I were to say, let's look at the z's. If I multiply this top equation by 6, then I'll have a plus 6z and a minus 6z. Now I could have chosen any variable. I could have chose the x's, the y's, it doesn't matter. I'm just going to choose the z's. Okay, so multiplying this top equation by 6 gives us 12x minus 6y plus 6z equals 36. Remember, you've got to do all of the terms by 6. And now I'm just going to rewrite the second equation under it. X plus 4y minus 6z equals negative 4. And now we add them together. 13x, negative 6 plus 4 is a minus 2y, those cancel, equals 36 minus 4 is 32. So I used these two equations to eliminate the z's. So I have to use a separate two equations to also eliminate the z's. So since this z has just a z, a 1, that's going to make it easier. So I'll use now the top one with the bottom one. And to make the z's eliminate, I would have to multiply everything up here by a positive 5. And where should I write this? We'll go off to the side over here. 2x times 5 is 10x. Negative y times 5 is minus 5y. 5 times z is plus 5z. And 5 times 6 is 30, equals 30. And our bottom equation, I'm just going to copy that down. 3x plus 2y minus 5z equals 5. And now add these together. Our z's are eliminated. 10x plus 3x is 13x. Negative 5 plus 2 is a minus 3y equals 30 plus 5 is 35. So what we end up with is just a system of equations where they're just two I'm tired, you guys. Where there's just two variables. They both have an x and a y. So we can put those together. I'm gonna rewrite this guy just underneath it. And now we can solve this system. Solving that system. Now I can't help but notice they both have a 13x. So if I were to take one of these equations and multiply it by negative 1, then we would be able to eliminate our x's. So the top equation I'm leaving alone. Bottom equation, we're multiplying everything by negative 1. Plus 2y equals negative 32. Now when I add them together, our x's are eliminated. Negative 3y plus 2y is negative y. 35 minus 32 is 3. Divide both sides by negative 1. Y is negative 3. Alright, so we've got now one of our variables. I got to finish solving this system by plugging in the y to find the x value. I could use either of those equations, it doesn't matter. So I'm just going to choose the top one, plugging in the y as a negative 3. 13x minus 3 times negative 3 for the y equals 35. 13x plus 9 is equal to 35. Subtract 9 both sides gives us 13x equals 26. Divide both sides by 13, x is equal to 2. So now we have our x and our y's. X, y, z is going to be our answer. X is 2, y is negative 3. We just need that z. So I'm going to take my 2 and negative 3 and come back over here and plug them into, I can use any of those three. And since I'm trying to find z, I'm going to use the top equation because it doesn't have a coefficient on the z, and that's just going to make it a little simpler for me. So x is 2, y is negative 3. 2 times x is 2 minus y, minus y, which is negative 3. 2x minus y plus z equals 6. Here this would give us 4 plus 3 plus z equals 6. And that would be 7 plus z equals 6. Subtract 7 both sides, giving us z is negative 1. 2, negative 3, negative 1 is our answer. Matrices. Fun. Find the values of the variables. Okay, we've got a 2 by 2 matrix equals another 2 by 2 matrix. So if they're equal, which it says they are, then corresponding positions are going to equal. So I highlighted the one that had a variable. Our t was there. So 4 plus t is equal to 10. See, corresponding positions equal each other. And so then I can solve that for t. Subtract 4 both sides. T is equal to 6. Now I'm going to look for my other variable right here. So that expression is going to be equal to 12. 4r plus 2 equals 12. Subtract 2 both sides. 4r is 10. Sorry, I zoned out for a second. Because I already made the key to this, and I was thinking I must have made a mistake because I remember getting 2 fractions. Maybe that was a different problem. Dividing both sides by 4, we get 10 over 4, which of course will reduce, cut in half, so we get 5 halves. R is 5 halves, and T is 6. Oh my goodness. You can do these with a calculator. Can't do this one with a calculator. Your calculator, we had those equations in there. So that one was a definitely do it by hand. These guys we can do with the calculator. So if you were using your calculator, you have to go in and tell the calculator what matrix A is. So under matrix A, this is a 3 by 2. 3, it always goes row by column. So they're both 3 by 2s. And tell the calculator, make this one be A, make this matrix be B, and then you can type it in. Mat, I forgot the 4 in front. We're trying to do this. So I'd go back to the run menu. 4 times mat A minus 2 times mat B. And we'll review that in class too, so I can remind you how to do that. You could also do it longhand. So we have to multiply before we can subtract. So I'm going to take matrix A and do, it's called scalar multiplication. Multiply all those numbers by 4. So that would give us negative 36, 20, negative 12, 20, negative 28, negative 4. Minus 2b. So now I'm going to multiply everything in that matrix by 2. 6, negative 16. Second row is negative 8, 18. And third row, negative 6, 8. Now we can do the subtraction. First row, negative 36 minus 6, negative 42. 20 minus negative 16, that'd be 20 plus 16, 36. Second row, negative 12 minus negative 8, that'd be negative 12 plus 8, giving us negative 4. 20 minus 18 is 2. Third row, negative 28 minus negative 6 is plus 6, so negative 22. And finally, negative 4 minus 8 is negative 12. All right. Same thing going on here. So let's get to it. For matrix A is the second one, that's multiplied by 2. Negative 8, 16, negative 16, negative 18, negative 12, positive 10. And over here, we're multiplying by negative 3. Here we go. 9, negative 24, 27. Bottom row, 27, negative 21, negative 6. So we found 2a, negative 3b, and now we can add them together. Negative 8, negative 8 plus 9 is 1. 16 plus negative 24 is negative 8. Negative 16, excuse me, I don't want to make dumb mistakes, so I'm trying to type in my calculator at the same time. Negative 16 plus 27 is 11. Then we have negative 18, where are we? Negative 18 plus 27. Negative 18 plus, that'd be 9. I don't need a calculator. Sometimes you get used to doing it and then you're not even thinking anymore. Negative 12 plus negative 21, so that would be negative 33. And then 10 plus negative 6 is 4. All right. Very good, very good. Multiplying, row by column, row by column. So if we multiply a 2 by 2 times a 2 by 2, in order to be able to multiply them, the inner dimensions have to be the same number, and they are. And the answer matrix is the outer dimensions. So our answer is going to be a 2 by 2. So I'm going to put big spaces to build a 2 by 2 so I can do the math. Here's our matrix, our answer matrix. All right, So it works row by column, row by column. So our first spot there, first row, first column. Well, I could delete that or erase that after I'm done. So it goes like this. -5 times 5 plus 1 times 1. Now I'm going to do, this is first row, second column. So I use first row, second column. -5 times -2 plus 1 times 4. Second row, first column. So second row, first column. 0 times 5 plus -2 times 1. And then our last position here is the second row, second column. Second row, second column. 0 times -2 plus -2 times 4. I'm just checking my math, or checking my, there we go. I think it all looks good. Hopefully I didn't make a mistake. Now just doing the math. -25 plus 1 is -24. +10 plus 4 is 14. 0 minus 2 is -2. 0 minus 8 is -8. And there we go. What is the product of this guy with the identity matrix? The identity matrix is like multiplying by 1. So whatever matrix that is a 2 by 2, any 2 by 2 matrix that I multiply by this gives you what you started with. So we're going to get the same thing. F, G, H, I think that's a J. Any matrix times the identity equals itself. Does the given matrix A have an inverse? If it does, what is the inverse of A? Okay, so you can do this in your calculator, type it in, and then you would, after you tell the calculator to make matrix A be that guy, we would type matrix A inverse equals, and out will pop your answer. And if it says math error or some kind of error, that means this matrix doesn't have an inverse. They, not all matrices actually have an inverse. And so we can also do it longhand. Sorry, I'm typing something in. Because I always forget the crossways. 2 by 2, 2 by 2 matrix inverse. Because when you're doing the switching of the stuff, I always forget if those switch and those guys go negative, or those switch and those guys go negative. But we can, so I'm just Googling it up. But we can begin this. So what we have to do is find the determinant first. The determinant is multiply minus multiply. So 3 times 3 minus 5 times -2. 9 plus 10 is 19. So the reason why you find that is because that's the denominator of the multiplier. We multiply this fraction by the matrix. And so that's the part I was talking about, of you take these numbers and you arrange them in here in a different way. And that was the part I was talking about that I needed to look up. And so it goes like, I just found it. So it goes like this. These guys switch places. I'll actually write the formula out. If your positions are A, B, C, D, then the inverse, well, they're not always A. The inverse is 1 over the determinant times D. So D and A switch places, and then B goes negative B, C goes negative C. So these guys switch places, these guys go to opposite sign. So they're both 3's here, so when I switch their places, it doesn't look like anything changed. Then, crosswise that way, they just switch signs. So positive 5 goes to negative 5, negative 2 goes to positive 2. And now we just do scalar multiplication. 1/19 times 3 is 3/19. 1/19 times negative 5 is negative 5/19. 2/19 for this one, and 3/19 again for that guy, and that's our inverse. Evaluate the determinant. So that was just this part of it. They probably should have asked number 15 first, and then that, because that's like baby stepping up to it. So the determinant, multiply minus multiply. So that'd be negative 2 times negative 5 minus 3 times 4. 10 minus 12 is negative 2. The determinant is negative 2. Another system, write the system shown as a matrix equation. So we don't have to solve this, we just have to write it as a matrix equation. So I'm seeing x, y's, and z's. So each one has some missing terms. We've got to include each variable, x, y, and z. So if I included the missing variable, it would be 2x plus 4y plus 0z equals 5. 2x plus 0y minus 2z equals 8. And this one's missing the x. 0x plus 4y plus z equals negative 8. So now, our first matrix is the coefficients of the variables. 2, 4, 0, 2, 0, negative 2, 0, 4, 1. Times our variables, x, y, z, equals our constants on the other side, 5, 8, negative 8. So that's all the question was asking us to do. Represent that system as a matrix equation. If you wanted to use matrices to then go and solve this, if you had to solve this system, then it would work like this. We have something times the variable equals something. Like, think about it like this. A times x equals b. I would divide both sides by a to solve for x. But we're talking about matrices. So instead of divide, I'd be multiplying by the inverse. So what I would be doing is multiplying both sides by this one's inverse. And so then you have to just think about your dimensions. If I put, well, let me first say, if we multiply both sides by the inverse, that's what makes those cancels. The inverses times each other give you the identity matrix. So they would cancel. So on the right hand side, multiplying that through, this is a 3 by 1, and this one's a 3 by 3. The inner dimensions don't match, so that wouldn't work for multiplying. So what we would have to do is put the 3 by 3 first, and then the 3 by 1 when we do it with the calculator. So I would make this one matrix A, this one matrix B, and that one's the inverse that we're multiplying by. So after I made the matrices, I would type mat A inverse times mat B. All right, but they didn't, I was just, in case that comes up. Oh, because look, it's happening right there. Where they just wanted us to say what the matrix equation was. So we're done right there. What is the solution? So I pretty much just explained it. We have something times x equals something. So I need to get the x to be alone. So that means multiplying both sides by the inverse. So I'm not going to write all the numbers in there, but both sides by that one's inverse. And that's the same problem again. This is a 2 by 1 and this is a 2 by 2. So we have to flip those around. So again, you could do this in your calculator, or you could do it longhand. So I don't have a calculator right here. I'm going to do this longhand. So I need to find the inverse of that guy. The determinant. 1 times negative 3 is negative 3 minus 4 times negative 2 is negative 8. Negative 3 plus 8 is 5. That's the denominator. Now we have to do the swapping and the switching stuff. Those guys trade places. Those guys go opposite sign. So positive 2 and a negative 4. Multiplying that through negative 3/5 negative 3/5, 2/5, negative 4/5, and 1/5. This would be so much easier just to use a calculator. So now that's the inverse, and we have to multiply it by the other side, which is a 2 by 1. So I've got them in the right order now. Inner dimensions match. Our outer dimensions is going to be a 2 by 1. So let's multiply 2 by 1. So that would be negative 3/5 times 8 plus, so we're doing this, 2/5 times 3. And now second row by column. Negative 4/5 times negative 8 plus 1/5 times 3. Checking on myself. All right. Nothing will cancel. So we've got negative 24/5. Oh, I didn't mean to write it right there because I want the answer to go there. Negative 24/5 plus 6/5 is negative 18/5. And down here we have negative times negative is positive. 32/5 plus 3/5 is 35/5, which is 7. Longhand is a pain in the butt. That's when the calculators make it so much easier. I think for straight regular old multiplication of matrices, it goes pretty fast and you get used to it. And it takes longer for me to type in all the matrices and do it. It's faster to just multiply. But when it comes to doing something like this, it definitely seems much, much easier to use a calculator, which you're allowed to do on the final, so we're good. What is the solution of the system? Solve using matrices. Okay, so we just did this one using matrices, and I explained this whole problem using matrices. I don't want to solve this using matrices. And when you're doing a multiple choice test, if they tell you the way to do something, but it's multiple choice test, just do the way that you think is the easiest way. And so you could use your calculator, or you could just solve it some other way. And so I'm just going to use the addition method to do this. So I need, if I were to say eliminate the x's, I need them same coefficient, opposite signs. So I'm going to multiply the top equation by 3, the bottom equation by -2. So that gives 6x plus 9y equals 30. And second equation, -6x minus 10y equals, what's 19 times 2? 38, negative. Now we can add them together. Our x's cancel. 9y minus 10y is -y. 30 minus 38 is -8. Divide both sides by -1. Y is equal to 8. And now I just have to plug in the y as an 8. I'll choose the top equation. You can use either. 2x plus 3 times y, 3 times 8 is 24, equals 10. Subtract 24 both sides. 2x equals -14. X then is -7. -7, 8 is our solution. All right, enough with the matrices. I like parabolas much better. Use the vertex form to write the equation using vertex form. So write this guy's equation in vertex form. So what is its vertex? Oh, it looks, I think it was meant to be actually on that, and it looks all squiggly, so it looks like this was hand drawn, or maybe just the generator was bad. I'm not gonna try to guess some kind of weird decimal. So we're gonna assume that the vertex is actually that point. And so that point is 1, 2, -3 and up 4. And we need the a value. So that's how, remember, that makes the parabola skinnier or fatter. If this was a normal parabola, normal legs, meaning a is 1. When a is 1, it goes over 1, up 1, over 2, up 4 on each side, over 3, up 9. But the point is, a is 1, that distance there. When you go over 1, how much is it going up? So looking, I'll use green. Over 1, 1, 2, 3. So a is 3. Y, or f of x you could use, equals 3 times the parentheses squared. So it goes opposite same. So x plus 3 plus 4 on the outside. Vertex form for the parabola. And I'm going to stop here at number 20, and then I'll make a second video because this is getting way too long. And my battery, as you can see, is down to 20. Suppose a parabola has a vertex of 3, 4, and also passes through the point 5, -6. Write the equation of the parabola in vertex form. We don't need to even graph this at all. We can do this all through algebra. The vertex form of a parabola, we already know this, a times x minus h squared plus k. So what we can do is we have the h and the k, and then we have just this other random point. Ordered pairs are x comma y, so what we can do is use this ordered pair to plug in the x and the y. So then we will have plugged in the x and the y, the h and the k, and that will enable us to find the a. Because those are the three things we need to write the equation. H, k, and a. We know h and k, we just need to find a. So that's where we use that point in order to find it. So let's plug in all of these values. Y is negative 6 equals a times, parentheses squared, in the parentheses, x minus h. 5 minus 3. And then plus k, plus 4. So I've plugged everything in. Now let's solve this equation for a. The a is times this value. 5 minus 3 is 2. 2 squared is 4. So that little chunk would be 4a. Negative 6 equals 4a plus 4. I'm going to subtract 4. Negative 10 is equal to 4a. Divide the 4. A is negative 10 fourths. But of course we can reduce that to negative 5 halves. I wonder if I messed up. Because I remember doing, I'm just going to go through. Y is negative 6. A, x is 5. Minus h is 3 squared plus k is 4. 5 minus 3 is 2. 2 squared is 4. Alright, everything looks fine. I just remember I said that I did the key, and I don't remember getting those numbers, so I don't know if I messed up on the answer key. I'll have to go back and look. Answer, y is equal to negative 5 halves times x minus 3 squared plus 4. Oh my goodness. So that is it for part 1. I'll do the second half probably tomorrow because it's like 8 o'clock at night and Miss Garcia doesn't stay up that late.